Okay, so now we're going to talk about that fundamental counting principle. Just basically being able to say how many outcomes you can have if you were to have a certain combination of items. So your outfit can be made of 3 shirts, 2 pants, and 2 pants. Draw a diagram for all the possibilities. So we have a red shirt, a black shirt, and I didn't think this through, but we'll use light gray, and a white shirt. Okay, and then for each of those, we have 2 different types of pants. So we have khakis and we have jeans. So we have khakis and jeans, khakis and jeans, khakis and jeans. So total, there are 6 combinations. So there's 6 outcomes. Now another way, I'm going to skip down to this part. Another way that we can determine the total number of outcomes is by multiplying the combinations together. So if you have 3 possibilities for the shirts times 2 possibilities for the pants, that's a total of 6 possibilities. So what's the probability that you have a red shirt and khaki pants? So if there's 6 total outcomes and we have a red shirt and khaki pants, there's only 1 possible combination. What's the possibility that you have jeans? So we have jeans here, and jeans here. So that's going to be 3 out of 6. And then what's the probability that we don't have a black shirt? So that's not black shirt, not black shirt, not black shirt, not black shirt. So that is 4 out of 6. Now I could reduce these fractions to 3 over 6 to 1/2 and 4 out of 6. But I like to keep the fractions as their original outcome numbers. So if there's 6 total outcomes, that kind of tells me more about the probability than if I were to reduce those fractions. So another way that we can think about this is something called a tree diagram. So a tree diagram basically lists out all the different types of possibilities that you can have. So if I say, what's the probability that you flip a coin 3 times in a row and land heads every single time? I can make a tree diagram to help me. So there's 2 outcomes for flipping a coin. You have tails and heads. And you have a 50% chance for both of those options. If I flip it again, I have another 50% chance of tails and heads. And then if I flip it a third time, 50% chance of tails and heads. And similarly, I have 2 branches off of the heads. So here is an example where I got a tails, and then a heads. So I can do the same thing over here on the heads to list out all the different types of possibilities that you can have. So tails, heads, each time 50%. These probabilities can actually change, like if you're talking about machines and being effective machines or not. Like if we say, what's the effectiveness of this machine? If it's, if a machine has like 20% effectiveness, we can talk about it using a tree diagram. So when it says, what's the probability that you flip a coin 3 times and land a head every time? I land a head in this case, I had a 50% chance of that. I had a 50% chance to land heads again, and another 50% chance to land heads. So what you can actually do is you can multiply those probabilities together to get the odds of that happening. So you multiply 0.5 times 0.5 times 0.5, and that gives you the likelihood of getting heads 3 times in a row. So when you have a tree diagram and we're talking about specific breakdowns of problems and probabilities, you can use a tree diagram to help you see the sample space and to see the probabilities of things happening. For this next example, we're going to just kind of talk about the notation that you would use if you were given a Venn diagram. So we have P represents the students with cars, Q represents the students with trucks. What does the shaded area represent in the picture below? So I'm going to start with this. I'm going to put this guy here. So I'm going to leave that representation 1 blank. And we're going to write the words and we're going to try to write the notation here. So we know that if everything is included in the circle, that's called the union. So that's the probability of students who have cars or trucks. Okay, for this next one, the only thing that's not shaded is Q. So that means I don't want Q. So that means students who don't have a truck. And maybe you're wondering why the outside here is shaded and what that could represent. So maybe that represents students who have like a motorcycle. So we actually call that something interesting. It's called the universe. So anything that's not represented in the Venn diagram is in that sample space outside of the Venn diagram, called the universe. Okay, here Q is represented, so that's just Q. So that's students who have a truck. And then we have this time the intersection. So that's the probability of P and Q. So students who have both a car and a truck, so lucky kids. Students who have a car and a truck. Here, I have everything. I don't want P, and I don't want the outside. So I'm going to say not P and Q. So not P and Q. Okay? So that is students who only have a truck. Okay? And then we have everything outside of the intersection, so that's not P or Q. So that's going to be students who don't have a car. Don't have a car or truck. Okay, so for our last example, we're going to look at a specific here Venn diagram. The Venn diagram, represents math students taking Miss Edwards' class, who are taking Miss Edwards' IF. So based on the Venn diagrams, okay, so we're just looking here at geometry and algebra students. All right, so based on the Venn diagram, we're going to find these probabilities. Again, the P represents that I'm going to find the probability. If it just said G, then that means I just need to find the sample space. So the first thing that I suggest when you're working with a Venn diagram problem is adding up all the total numbers so you have the total sample space. Because whenever you do your probabilities, it's going to be over the total number of samples that you have. So 3 plus 17 is 20, 20 plus 5 is 25, plus 11 is 36. So every one of these probabilities is going to be out of 36. So what's the probability of geometry? So geometry is the 17 plus the 5, which is the 22. The probability of algebra is the 5 plus the 11, so that's 16. That's everything in those circles. The probability of geometry and algebra is the intersection, so there's 5 that are overlapping. The probability of geometry or algebra is everything inside of these circles. So 17 plus 5 is 22, plus 11 is 33. And then my last one is everything except for algebra. So that's this guy, not him. He's in the circle for algebra, not him. And this guy. So that's going to be 20 out of 36. So give these next Venn diagram set notation homework questions a try. Make sure to ask your teacher if you guys need help.